Good morning, good afternoon, and for those of you in Asia, good evening. This is Phil Laidler. Welcome to STL's webinar on virtualization, reaching the tipping point. My name is Phil Laidler. I head up the consulting practice at STL Partners, and I will be facilitating the Q&A session at the end of this webinar. So first of all, thank you for joining. Looking forward to spending the next hour taking you through some of our thinking and also interacting with you throughout the session and sharing your views. What I'd like to do is just quickly introduce the speakers and run through today's session. So there's myself, obviously, heading up consulting practice. The first speaker will be David Martin. David's one of the senior analysts and the author of many of our reports on NFE SDN. He also is the force behind our NFE SDN tracker that he's compiled and maintained over the years. And he'll be really providing an overview, really within the context of 5G and recent developments. You know, question, or at least addressing the question, is NFV about to take off? That's where David will be focusing his presentation. He'll be followed by Matt Pooley, who's a member of the consulting team here at STL Partners. He's a senior consultant and also leads our virtualization practice here. And he's going to be offering some views on how we think that journey is going to evolve with operators going forward. So looking forward to having them. Welcome all of you who have joined today to listen to them. Very briefly, those of you who are not familiar with GoToWebinar, the platform we're using today, you'll find that there's a control panel. You're all muted. So if you'd like to raise a question, please use the panel on the right hand to enter your questions. I will be reading and checking the questions throughout the next 40 minutes during the presentation. And the last 20 minutes, I'll be trying to process those and as far as possible, pose those questions back to our two speakers and get their response to that. So that's the format we've got for today. Please use that. If you've got any issues, do raise your hand and raise questions along the way. My colleague Darius may try to help resolve any technical issues any of you have found. Please do go ahead and tweet about this as much as you like during the course of the session. And I should mention that slides that we're showing will be made available to all the attendees at the end. And also at the end of the webinar, we will ask you if you have a moment just to fill in a quick survey summarizing how it went for you and how you thought of it. So I think that's basically all of the basic setup for today. Let's move forward without further ado and introduce David Martin to take us through the key question in terms of network virtualization. Have we reached a tipping point, David?
Thank you very much, Phil. Hello, everybody. So sort of question that I'll be asking is very sort of overview type question. What's happening with TelcoNFV? We can move to the next slide. So the data that the discussion is based on is that of STL's NFV deployment tracker, which is a comprehensive and reliable source of market intelligence on NFE and SDN in live telco networks. It's updated quarterly and comprises an Excel spreadsheet, which contains the global database of information on live deployments, as well as a rolling set of regional and global analytical reports. And there's a couple of snapshots from recent updates. So moving on. So the data specifically is taken from the latest update of the tracker, which is due to appear at the end of this month. And that includes information on 479 live commercial deployments of NFE and SDN across 105 mainly tier 1 networks. I should stress that these are live commercial deployments, so we don't log in this database the proofs of concepts or the pilots. This is sort of live stuff that's powering commercial services, and it is mainly tier 1 networks, although we do also highlight and cover deployments that are particularly interesting or challenging or innovative as well by non-tier 1 players. The data is drawn mainly from public domain information, from operators and vendors themselves, and from respected industry news media, as well as a certain amount of confidential information from operators that is included in an aggregate anonymized data set. So on the next slide, this is the last sort of preliminary bit here, really. How do we define a deployment? Well, you have the definition there. It's more than just a single virtualized network function that we tend to include in our deployments. It can be also reference all of the subcomponents and the infrastructure elements that support that deployment. So for example, in the case of a virtualized evolved packet core, we might also cover some of the infrastructure and some of the management components, and that would all be counted as a single deployment. So as you see there, we've got 479 deployments, but the database in fact includes 1,000 rows of information on network functions and infrastructure elements that are included within those. And similarly, if an NFV platform is rolled out across multiple subsidiaries, national subsidiaries, for instance, of a global operator group, we would count that as a single deployment. So we wouldn't necessarily recount that as multiple deployments if it's the same platform rolled out across multiple subsidiaries. And so there's quite a lot of, that's fine. We'll move on to the next slide. So here is the sort of first picture of sort of data as a sort of overview of how the market has evolved over the last few years. And we see that we did sort of track a slowing down of growth during 2018. Now, I should stress that these bars are total deployments in each year. They're not cumulative totals. So, so they're new deployments for each year. The deployments appeared to slow down a little bit, the growth appeared to slow down a bit in 2018, but we think now we're detecting an increase. So if we go to the next part of this slide, the 2019 figure includes the bottom bit, the dark bit is deployments that we know have been completed in 2019, and the larger bar in amber is those that we're expecting to be completed. So they've been announced, they're happening, and we're expecting them to be completed by the end of 2019. And of course, that data is only up to April of this year. So by the end of 2019, it's reasonable to expect that we will see about 150 to 200 deployments in 2019. So growth definitely picking up again. So on the next slide, we have a poll for you. Let's see the next slide. Can we move to the next slide? So here's a little poll, which you should see appearing on a separate screen. We're asking, here we are, what is driving NFV deployments today, in your opinion? So please select one of those. I'll give you about 15 seconds to half a minute to complete that. So is it the move to 5G? Is it cost cutting? Is it growth in 4G services? Or is it new service innovation and business models? So if you would care to sort of fill in your options, maybe you don't feel any of them apply, in which case perhaps you could raise that in the Q&A afterwards. So I'm going to count us down to the end of the poll now. 5, 4, 3, 2, 1. Okay, we'll now finish making our selections. And here's the answer. That's very quick. Most people, the largest number said service innovation and business models, which is quite a refreshing conclusion in some respects. Cost cutting, 29%, move to 5G, 26%. Of course, that's actually the main focus in this present discussion is looking at the role of 5G. So that's a very interesting survey result. Can we move on to the next slide now? So if we go on to the next bit. So here's a rather busy sort of slide, so I'll have to sort of unpack that for you, which looks at the deployments by primary purpose over the time period where NFV has been sort of happening, 2014 to 2019. Now, by primary purpose, we mean that we take, for each deployment, which, as I said before, might contain multiple elements to it, multiple VNFs and infrastructure components, we sort of take the view that there's one overriding purpose that they have. So it might be to virtualize the mobile core, in which case that's the core NFs column on the left. It might be to roll out an SD-WAN platform and service, or it might be to lay down an SDN infrastructure platform, or to roll out an NFV Mano platform and things like that. So we sort of, for each deployment, we're taking a view as to what the primary objective is, so that there's just, so each of those numbers represent single deployments. And as you can see from the red sections at the top of each of those columns, the overwhelmingly largest component in 2018 and the first 4 months of 2019 has been virtualized mobile core deployments. In fact, so much so that in the first 4 months of this year, there have been almost as many rollouts, that's launches of services based on virtualized mobile cores, 34 in total, as in the whole of 2018, which was 37. So in 2018, we did observe a reluctance by leading operators to commit to virtualized mobile core platforms for a number of reasons, including uncertainty as to whether they were really 5G ready, and also, evolving 5G strategies. Doubts about whether those virtualized platforms were really going to deliver the performance and the cost savings that were required. And the demand for cloud native vendor neutral platforms that operators have felt that many vendors were not actually delivering or offering. In 2019, by contrast, I think we have observed a trend that vendors purportedly cloud native 5G platforms are winning additional business. And that's the subject of the next slide. So here is a sort of view of the virtualized mobile packet core deployments and the leading vendors in that particular area. Again, in the whole of 2018 and the first 4 months of 2019. As you can see, Ericsson and Nokia are pictured in the front there. Now, some of those numbers might appear rather low. Suddenly, if you read the press and the vendor saying, oh yes, well, we've got 45 contracts or 50 contracts in the 5G area, including the packet core. But we have to bear in mind that these are actual deployments, so they're not necessarily agreements to deploy, or even MOUs to work together on developing some of these packet cores. These are actual live deployments, and they're ones that have been verified. So there undoubtedly have been more actual launches and deployments during this time span, but they haven't always sort of hit the public domain. But these are verified, so this is hard data, this is actually happening. So Ericsson and Nokia in front, affirmed networks, we have logged 6 deployments. Huawei 5, now of course the question is, has Huawei been hurt by some of the bad news recently? I don't think we have enough evidence to support that, partly because there's probably a lot more going on privately, not in the public domain than we know about. But an overall sort of takeaway from this particular slide is that we think that a lot of these successes are being driven by vendors' cloud packet core platforms. Now, they're marketing these solutions in a different way than they've done before. They're not virtualized evolved packet cores. They're cloud cores marketed as cloud native with disaggregated software functions, multi-vendor capable, so they market them as platforms which other vendors' solutions can be deployed onto. And there are some examples of that, quite prominent ones that have been in the press recently. So there's obviously Rakuten in Japan, very sort of high-profile multi-vendor deployment, and the core elements there combine both Nokia and Cisco components. There's a big multinational Telenor deployment where some Ericsson core VNFs have been onboarded to a Nokia cloud packet core platform. And KT, Cisco is still in the game, big sort of deployment there, supporting KT's very recent consumer 5G service launch. So maybe we could move on to the next slide. And this is sort of taking a sort of overview that's looking at the leading types of NFE and SDN deployment that are have been happening in the different sort of focuses region by region and how that affects the overall total. So this is recent data as well. So it's 2018 full year and the first 4 months of 2019. You see that Europe is the leading region overall, followed by APAC and North America. And in each of those, well, certainly in each of those regions, it's actually the core virtualization that is the leading category, clearly driving growth, and particularly strong in Europe. And in fact, that's building on a historical record of considerable focus on mobile core virtualization in Europe over the last years. But as I say, it's evolving to a more cloud-native type structure. SD-WAN also strong in Europe. It has been the top category in North America since 2017, but the volume of new deployments is falling there. And that's partly a reflection of the fact that the telcos, the leading telcos certainly have now rolled out their SD-WAN platforms and services. So the volume of new launches has declined. And in Asia Pacific, we noticed that historically, there's been a very strong trend of quite innovative SDN-based services, including transport SDN, and that's still prevalent now. And obviously, mobile core is a very strong element there as well. Overall, Asia Pacific, across the whole time span that we've covered since the start of NFE and SDN, Asia Pacific is still the leading region overall, with 33% of the deployments in our database, followed by Europe on 32% and North America on 25%. So maybe we can move on to the next slide. So this is the operators, again, very busy slide, which I'll have to try and unpack for you. So this is the leading operators across the whole of our database, not just recently, the whole period, mainly 2014 to now, in terms of the number of deployments. And we see Vodafone out in front, and its recent activity has been very much focused on NFV infrastructure, NFVI, with a sort of high profile news release recently about the role that VMware is playing in the deployments and the extent of the deployments there. I think it's about 50 sites across 15 markets, 15 country markets, and a lot of mobile core activity going on in there, and Vodafone as well, including some non-public domain information that's included in the aggregate data set. Telecomunica, again, very big emphasis on the NFVI globally, and a recent report that it's more or less finished the rollout of its Unica global NFV infrastructure, telco cloud, and a lot of virtualized evolved packet core activity as well across all its markets, including Latin America, some of which is taking a bit longer than planned to sort of finalize and deliver the performance benefits that are demanded. Now, at Verizon and AT&T, you might be a little bit surprised that they sort of appear to be lagging compared with Vodafone and Telefonica, but that's partly because they have a mainly single market focus. So in terms of the actual way the database mechanics work, we're not logging multiple virtualized core deployments, for example, if they're using a different vendor and a different platform. Across multiple markets, there's just the one market and the one set of deployments there. And the focus recently has been very much on 5G, including the infrastructure, radio access network, and core elements. AT&T is an interesting case in point that I might sort of come back to, which is that, well, in fact, both operators have been rather cagey, shall we say, reluctant to disclose too many details about the vendors and the architecture that they're using for their core. AT&T is deploying it onto their recently rebranded Airship SDN and NFVI, which uses has a strong emphasis on containerization. So you know, potentially AT&T is already sort of doing its mobile core in a truly cloud native manner, but it's not clear exactly you know, what vendors and technologies are involved and what the architecture is. And some of these other telcos that are, appear to be slightly behind the curve is partly because they haven't really disclosed a lot of information about their mobile cores either. And that's in itself an interesting observation, that obviously a lot of work is being done in the area, but not so much publicity by many of the players involved. SK Telecom, out of all of the other leading players here, is the only one that has disclosed some information about what its mobile core virtualization supporting 5G is involving. In fact, it's Samsung rather than any of the other vendors that one might normally expect to be leading that particular charge. So if we can sort of go on to the final slide in my part of the webinar presentation. So preliminary conclusions from the NFE deployment tracker data is that, in fact, mobile core virtualization and preparations for 5G are driving growth in NFE deployments, but it's arguably the case that cloud native and certainly 5G mobile cores are still some way off, and that's something that my colleague Matt will be going into more detail about. I think the evidence, at least from the commercial deployments to date, is that to some extent telcos are buying into vendors' promises that their cloud native mobile packet cores do present a viable migration path from 4G to 5G. In other words, from non-standalone 5G cores, basically built on the same architecture and functional systems as the existing 4G core, to a more standalone 5G core. But there are very substantial issues still outstanding in terms of, the core architecture hasn't been finalized, and NFE in general, regarding some of the more longer term objectives surrounding NFE, such as software standards, performance, costs, return on investment, vendor neutrality, use cases and business models, and this question that that I want to sort of foreground is, whether the software being delivered is yet really truly cloud native, sort of truly disaggregated and reconfigurable and recombinable in a more flexible, agile, vendor neutral way. Final sort of words. So arguably no one has yet, I would say, delivered a truly cloud native virtual mobile core, let alone a 5G core, even though 5G is in fact providing an impulse to new growth in deployments and virtualization. So I'm going to hand over to my colleague Matt now, who's going to drill down behind some of those sort of headline numbers and to look at the evolution path from 4G to 5G virtualized cores.
So David, this is Phil again. Thank you very much for that and for being spot on time as well. Just want to remind everyone, if you have any questions that are generated from the presentations, please do go ahead and submit your questions into the tool on the GoToWebinar, and I will seek to respond to them accordingly at the end of the two presentations. So moving on, after David has provided a very thorough and detailed overview of the current state of deployment, we're going to invite my colleague Matt to take us through how we see things evolving going forward. So Matt, please go ahead and take us through the outlook for virtualization.
Great, thanks Phil, and hi everyone. I think you're right that David's given us a great overview of what's going on. As you said earlier on in the call, my role sitting on the consulting side of SDR's business is a little bit more around answering questions related to what's going on. And I think I've come in here to sort of try and tackle the title of this webinar, which is virtualization at a tipping point, and is 5G the kind of compelling event that's pushing us over the top here? A bit of context for this. One of the things that we've been asked in a few different ways by operators and vendors that we work with over the last few months is, did the industry miss the boat with NFE and 4G? NFE is a story that everyone kind of bought into. It promised some great stuff. We've been talking about it for a few years now, but it took quite a while for stuff to kick off, as the data showed. And some people have sort of said, look, with 4G, we've missed the point, and perhaps 5G is our opportunity to really, pick up here if we can overcome some of the challenges that David's talking about. I think, and I'll go into talk about this in a bit more detail, I think the answer is a little bit more nuanced, because we actually think there's a lot of scope for virtualization within the 4G sphere that will help support that journey towards 5G. Starting from the beginning though, I think we just need to establish up front that 5G is happening and everyone's going to do it in one form or another. I think there's lots of discussion around the lack of a killer app and the lack of a real exciting business case for 5G, and we discussed this in a recent webinar, so I won't get too much into details. It is happening. We are very close to, fixed wireless is already out there and working, very close to mobile coming onto the scene. The industry is moving in that way, and regardless of whether you think there's if a killer app will ever emerge, there's no debate that the cost implications, the speed, performance indications, the capacity, and also the excitement that 5G will generate among your customer base, we're already seeing it in the press. 5G is going to be a powerful tool, and operators around the world are trying to get their head around how to make the most of it. Not getting too much into the complexities of that, we are now starting to see a sort of, we've called it an investment cycle here, but a sort of roadmap for 5G deployments emerging. Starting with what we've already seen, which is stuff around using 5G to enable fixed wireless access products, towards, in the not too distant future, 5G for enhanced mobile broadband using 4G as a fallback, developing towards at some point in the distant future. And this is based on, a little bit what we see happening in the States, a little bit where we think it's, standardization is going to play, and where we think it's all going to crystallize. We may not be quite right here, but some point out in the future, purely 5G core supporting that enhanced mobile broadband. And then there's the other sort of use cases that we've been talking about as an industry for the last few years, using 5G to support massive machine IoT solutions, ultra low latency coming in a little bit later on once everything starts to mature, and also very specific vertical solutions supported by network slicing, all of these buzzwords coming into effect. There's a lot that will need to be done to get to what we've got on the right hand side of this timeline here. But if you look at what we're very close to be doing, or already doing to some extent, actually it's very close to reality and very close to what we have already been doing. And it doesn't take much to move from where operators are now towards enabling both of these things. And to explain that in a bit more context, there's quite a clear technological evolution path starting to emerge. So think about 4G right now, and I will say up front that this is a grossly oversimplified representation, and there are lots of nuances of which we won't get into too much detail today. But 4G today, you've got the LTE radio protocol, and you have the mobile packet core, the EPC. They work together. It's well established. It's out there. We're running networks on that all over the place. What we're starting to see now is operators moving towards what we call CUPS, control and user plane separation. So taking the packet core and logically separating the control aspect of that and the user plane aspect of that. And there are various different ways you could do this, but in essence, you're starting to softwareize it, and you can then potentially, push some of the user plane stuff out towards the edge of your network. Should that be, should that be beneficial to you, and whatever. So we've represented it as clouds here. It doesn't have to be clouds. We won't get too much into the details, but it's more or less what we've already got, but logically separated. Now we see that, which is already happening in operators around the world, as a stepping stone towards what is being called option 3. And there are various different flavors and variants of this. But in essence, that's using that same logically separated 4G core together with the 4G radio that you're already using, the LTE, and the emerging 5G new radio, which is starting to come out into play. So rolling out 5G radio as and where you see yourselves wanting to use it, but still using the LTE core in order to support that. There's then a very tricky, long-winded transition phase towards what we might call proper 5G, where that 4G core is replaced with the new 5G core as and when it emerges. We're quite a long way from that, and knowing what that looks like. I think there's various different pathways that different operators will take in order to get there, so on and so forth. But these first 3 steps are already possible and leave the door open to getting down towards proper 5G, as I'm calling it, whenever those steps become clear. So CUPS is happening now. In fact, a lot of the deployments that David's talking about around the 4G mobile core that we've got logged in our tracker include control and user plane separation as an element of that. And we're very close to, or it's already happening to some extent, moving towards this option 3, using the 2 radios alongside each other. Who knows in reality when we'll be using a fully standalone 5G core, 2020 plus. There's still a lot of standardization to happen, and the ITU standards 5G is still, I think, down to be sort of crystallized around 2020. But what is clear is that virtualizing your 4G core is a clear step towards 5G. So if you think back to the question I was asking, did we miss the boat? Well, perhaps we missed the boat in virtualizing 4G networks for the benefit of 4G networks. But if we're thinking ahead to 5G, we can still do a lot with our 4G networks that will keep the door open for more stuff down the road. So it's a little bit more of a nuanced answer, I think, to that question. It makes sense in essence. If you think about the challenges that we've got going on in mobile operators at the moment, obviously 4G is still a very big challenge. Data traffic is growing fast across the world, even if the revenues aren't coming with it. We were talking to an operator client of ours recently that had seen 80% increase in data traffic year on year, and most of that was from Facebook and YouTube videos. Same user base, same share as before, just their users making a hell of a lot more use of their network. And we've spent a lot of money as an industry on 4G, and we need to make sure that we're getting the value for money from that. We're not dumping that just because 5G is coming along. We've got big investment cycles to think about, so on and so forth. Alongside that, however, there is a lot of pressure mounting to deliver 5G. That's very difficult because the 5G core is a way out. We've got vendors working on it and proofs of concepts going on, and so on and so forth. But there's still a lot of uncertainty and things to figure out before we really get there. So what we're seeing is among the tier 1 operators that David is tracking is that they are using virtualized mobile core to support new and end-of-life 4G traffic. What we mean by that is they're using that to support additional capacity that they have to add to their networks, and also as kit comes to an end and needs to be decommissioned, they're replacing it with virtualized stuff. And what we think is that makes sense, not just for the tier 1s, but for mobile operators as a whole, for a couple of reasons. Firstly, it will help you to cure your headaches around the cost of that big traffic growth that we're talking about, but it also, in the meantime, means that the money that you spent on the stuff you've already rolled out wasn't wasted, and you can really sweat those existing assets. But, and this is the important part, it will help prepare you for your 5G rollout, not least because it will help you get your head around how to, I've called it adapting to cloudy operations, but it means work with the new stuff. It's pretty easy. Thinking back to the option 3 I was talking about, to sort of bolt on the 5G new radio as and when you're ready, and you will be, as I've argued, in a good position to move towards the 5G core as and when it becomes available. Alongside this, I think we're seeing a growing effort push to overcome some of the caveats, some of the things that operators have said, the industry and in fact as a whole has said has been holding us back from really jumping at network function virtualization, not least performance, reliability. You know, what we're hearing from operators is we need VNFs to work better, inverted commas, than the physical functions that came before them, more reliably, quicker, so on and so forth. We're not going to replace something with something that is slower and doesn't perform as well. Why would you do that? We also need it to work properly at scale, and there were questions around whether that was possible. I think what we're seeing now is that increasingly and publicly as well, in a lot of cases, the operators are putting a lot of pressure on the vendors here. We are starting to see, you know, improvements in performance of the functions. We are starting to see increasingly open sort of competitive platforms, ecosystems emerging. Your mileage may vary on that last claim, but we're starting to see people moving in that direction. The other question David's raised is around, you know, when the truly cloud native stuff starts to come around. And in fact, I was at the TM Forum event in Nice last week, and there was a lot of discussion about this and what it means. And you know, operators saying, why are you talking about this if you can't deliver it, vendors? But what this means is, you know, a sort of software first mentality, thinking about microservices, containerization, not just throwing the old stuff in a virtual machine and hoping it works. We are starting to see moves in this direction. The vendors are now talking about this much more openly than before. We're seeing telcos experimenting with it. David mentioned AT&T. We're starting to hear in discussions with our customers, you know, stories of the network functions being rewritten, or you know, operators going through or the vendors going through code line by line and figuring out where they can containerize, so on and so forth. So we're starting to move in that direction, overcome that problem. It's going to take a while. And then obviously the other thing is 5G mature enough? We need it to work. We need it to be available. I think, as I've said, that's already happening. We've already got the radio out there shipping, or you know, I think all the NFPs are doing it, or if not, they're very close behind. We've got fixed wireless access out there. Our analysts think that, you know, real commercial mobile 5G is within the next year, with some caveats, and we know that the vendors are pushing very hard to you know, get towards that mature cloud native 5G core that we're talking about. Obviously, lots to work on in all three of these areas, but certainly the momentum is now building, and I think that we're going there. The industry wants to solve these problems, and to do this, which would suggest to me that virtualization is at a really great point to what I've called go mainstream, but extend beyond those few sort of tier one operators and become the thing that mobile operators of all shapes and sizes start to really push for and move towards over the next couple of years. I would be really intrigued at this point, just before we go into Q&A, to see whether you agree with me, whether we've managed to convince you. So we've got a vote here. The question we asked today is virtualization at a tipping point? I want to know whether you agree. Do you think, yes, okay, of course it's going to happen now? No, you've got it all wrong, and I know there's a lot more nuance to both of those answers. But also, thirdly, perhaps, but I think we need to understand a bit more about it. We need a bit more evidence. So I'll give you a couple of moments now. I would imagine, like to play a predicty Mystic Meg game, that most answers will be on number 3 here, but I would love you to prove me otherwise. So please be honest. We'll give it another 10 seconds or so, and then hopefully we'll be able to address some of the questions that you had. I know Phil is buzzing to ask me. Make sure I stick to time. Okay, 5, 4, 3, 2, 1, and stop answering now. And what we found is, oh, I was not right. which is good. It's always good to be surprised. I think it's pretty clear that you are agreed with me to some extent that virtualization is a tipping point. Very few saying that it isn't. Some saying I think we need a little bit more info. Fair enough, and we'd be very happy to talk about that and answer your questions about that in the next part. So I'm going to hand back to Phil at this stage to lead us through the Q&A. Thanks.
Thank you very much, Matt. Thanks for that good overview and that outlook. And you managed to get that also spot on time available. So thank you for that. What I'd like to do now is just had quite a few questions sent in. Some of you have been sending in your questions on the questions. Some have been sending back to the organizer. That's fine. We're processing both of those. I think one question that's been asked, which is a fairly good one, and clearly, you know, Matt, you've slightly oversimplified things by showing a couple of little clouds. The question really is, what does cloud native and what are cloud native functions, and what do they really mean? So for you, what is that definition of, you know, cloud native, and what are the slightly less than cloud native flavors of virtualization that you haven't really you've glossed over? But perhaps you and after that, David, could share your views on that question.
It's a great question, and in fact, it's a question we don't have a solid answer for, and it's going to be a focus, I think, of our research over the next couple of months. I've been talking to different players in the industry, operators, vendors alike, about this. It's very nuanced. I think broadly, when operators are asking for cloud native, we're talking here about a philosophy rather than something very specific. It's about things that are designed cloud software first, if you like. So to give an example of something that is not cloud native, it's how we've seen a lot of virtual network functions being deployed, which is in essence running the physical network function that already existed in a dedicated ASIC-based appliance in a virtual machine. Simple as that. A very kind of one-to-one relationship, VM to VNF, etc., etc. Not really optimized, not really rewritten, softwareized, so on and so forth. I think the concept of moving towards a more software-based approach is what operators are talking about here. Now, I had an interesting conversation last week with, he wouldn't want me to name him, but a gentleman at one of the virtualization players who was saying to me that the problem here is that there are many different ways of defining cloud native, not least the fact that cloud native is actually a well-defined term for software design, in which I think there are 7 sort of different tenets which an app has to meet in order to be cloud native by definition. I don't think that's what operators are talking here. I'd be interested to see if David agrees with me.
Yes, I think I broadly do agree with Matt. I think at a sort of straightforward level, it is about a software first approach to network function design and network design in general. So it is about, I suppose to some extent is based on what your starting point is. So as Matt was saying, the starting point for NFV initially was to take the existing hardware ASIC based functions that everybody's familiar with and to port them into virtual machines, and to sort of deliver some of the benefits that NFV promised, based around being then able to scale the capacity and to scale out as well as to scale up, you know, much more flexibly, but still based on the same set of functions. So as well as being a software first thing, I think cloud native is about evolving the actual functions as well, by disaggregating what we've got now, splitting them out into much more the sort of component parts, the microservices, and being able to be much more innovative about how they're sort of taken forward, how they're developed, how they're recombined, using orchestration, using containerization, really having the ability to proceed not so much from what we already have, but sort of using software, using the agility to evolve the functional sets themselves and to be able to deploy those in a much more flexible, agile way, which cloud allows you to do, in terms of not being bound by particular hardware suites and platforms. So I think it's a mixture of a number of components, but I think it's really about sort of where you start from and what your goals are, and the being freed up to innovate and develop functionality and develop new services, perhaps more also in a more intent-based sort of way, so that you're actually starting from the service logic and finding a way to actually deliver that in a more flexible, agile, software-centric way than has been possible for telcos up to now. So that was probably sort of quite a lot of things in there, but I think that's how I would see it.
Great. I think something actually I wanted to ask you, David, but sort of going back to the earlier part, you were talking a little bit about Telefonica and Unica, and we had someone submit a question about this. You said, rightly, based on what's out there, that Unica is Telefonica is trying to kind of finish that off now. I can't remember how you phrased it. It's interesting. What we were asked was, well, wasn't it, if you look at the framework, the steps that they set out in the white paper that they put out a few years ago, wasn't Telefonica meant to have fully virtualized in order to be ready to enable 5G networks by now? What did they mean by that? And is what they've got done so far really enough to justify that claim? I don't know if you have any thoughts there.
Yes, well, there's a lot of things in there. I think it's undoubtedly the case that Telefonica was expecting to be much further down the road in terms of virtualization and having that sort of standardized global NFE infrastructure platform in place now to then be able to launch 5G and other new services based on a fully virtualized platform. I think they haven't succeeded in doing that for a number of reasons, and it's very complex. There's organizational factors, alongside technological factors, and the fact that the performance hasn't been there from the solutions that they've tried to onboard onto the platform, and it's an extremely complex set of issues. But I think again, you have to sort of separate what they claim from what is the reality, but they do now claim that they have rolled out Unica. So the Unica platform, is if they're to be believed fully now in place, but they have also been doing a lot of virtualization on top of that. And they haven't yet succeeded, as far as we sort of know from conversations that we've had, in really delivering that sort of cloud native architecture, if you like, that they're still trying to sort of do virtualized evolved packet core, really not based on what their own target architecture is, simply to deliver the sort of benefits that they need now in terms of performance and capacity, and also to get, as Matt was saying, the kind of experience in sort of virtualization and cloudified operations that they will need to take it on to the next stage. But I think it's probably fair to say that they haven't yet moved on to that next stage, which that's that stage being 5G and fully cloud native operations. And it's a long and bumpy road, and they've certainly had a lot of bumps in their road.
Great, thanks a lot, David. We've got one quick question, and then I think we got some questions more related to the radio access network and vRAN. So it's just a quick question for you, which is more about the tracker, I believe, which is, do we separate out the virtual network functions and the network function virtualization infrastructure, the NFVI, in our tracker?
Yes, so we do separate them out insofar as we log basically all of the information that is available.
So David, I think that's just a question about the tracker.
Yeah, can you hear me? So yes, in terms of
Yeah.
the tracker, yes, we do separate out those pieces of information. So for each deployment, we will sort of log in the tracker the full set of information that's available to us about the different components of that deployment. So that might be the VNFs, and then we'll also contain what is known about the infrastructure platform, or about the MANO systems, or the SDN components, and so on. So we will present those. We present that information in as detailed and broken down, format as we possibly can, separating out those different aspects.
Okay. It's just we didn't particularly in the slides today, but the data's there in the tracker and,
it is,
and,
oh,
and
yes,
available.
Details,
Great.
yes.
A couple of questions then we've got here relating more to VRAN. We've got a question from Joseph, which is more about to what extent do we see VRAN gaining traction, and what evidence have we got relating to VRAN? So maybe David, you with the tracker, have you got any comments or any early observations regarding VRAN deployments?
Yes, now we do have a limited set of data on VRAN deployments, and that's partly obviously because, in fact, there's only been a very limited amount that's actually been deployed in live telco networks. I mean, and obviously everybody's familiar with the different groups that are working very actively on VRAN in terms of the architecture and the standards and so on. I think there's about 3 different industry groups that are working actively with a lot of vendor and operator participation. But in terms of actually live stuff, very little there. There was a deployment by Telecom Italia 2 or 3 years back in the city of Turin that they were expecting to go to extend to other areas, but I think they didn't. They decided not to actually do so. I think Verizon's been active in that area, and that, but again, I don't think much has actually been deployed. There's a Turkish vendor called Argela, and they did a programmable RAN solution for I think it was Turk Telecom, which is now live in sort of, but mainly only in business centres in Turkey. So there's very little that's actually live now, but obviously it is a key area, and obviously related to what we've been talking about in terms of 5G and distributed operations and the sort of operational efficiencies and programmability that everybody hopes that NFE will be able to deliver to support the new 5G use cases, but not much actually live now.
Great, thanks, David. So there's a sort of follow-up question, and it may not be specifically to VRAN, it may be slightly broader, but it seems to be around that. And the question really, slightly contentious, but very topical, relates to the way that Huawei currently, with the press coverage, is often mentioned in certain countries as if operators are unable to deploy Huawei technology, they may face delays or higher costs. And I think the questioner is asking, well, how come nobody's talking about alternative providers and perhaps some of the startups who could potentially be the stars challenging traditional radio access network vendors with their VNFs? Is it your impression that operators are not taking them or as seriously as they might, hence the press coverage relating to Huawei?
That's it's a good question. It's difficult. It's very sort of intricate and delicate issue. But I mean, there have been a number of operators that have actually stood up and said, well, we're not going to bow to, the pressure from the US or from regulators. We are going to stick with our existing relationship with Huawei, and similarly, obviously, not just the challenger vendors, but the established vendor competitors such as Nokia and Ericsson have sort of, obviously part of their play now is to try and sort of replace Huawei in terms of the sort of mobile 5G ready cores. And I think there is quite a bit of that going on. It's very difficult to sort of see what's going on beneath the surface. I think there is a very good opportunity for challenger vendors there. Equally, of course, as I say, it's a big opportunity for the likes of Ericsson and Nokia. What I would sort of say in relation to that is that there is a bit of a paradox, as I see it, in terms of the way all of this issue with Huawei is being talked about, which is based around the actual software itself. There seems to be an assumption that in fact the solutions that Huawei might be delivering in that area are to some extent proprietary solutions that Huawei, could, in theory, put in some codes and some backdoors that would enable breaches of privacy and security and so on. But really, in a sense, the whole point about 5G is actually to move away from closed proprietary solutions. And I think there's more to sort of be, there's more around this whole business of, the degree to which open platforms and open source versus more vendor proprietary solutions. And I think there's a lot that's going to play out in that area. And certainly, I think for sort of the open source and challenger players, I think there's potentially quite a lot of ground that they can actually exploit there in terms of saying, well, actually our systems are transparent, they're open, and open source is a way in which we can mitigate these security risks. But equally, is Huawei, one of the proprietary players, because Huawei itself has been quite strong in the open source, standards development. So I think this is a complex issue. It's not easy to say which way it's going to turn.
No, and quite delicate, I'm sure. I kind of closing up for time, so it leads on to another question I've got here, which is the operators and maybe perhaps some of the mid-tier operators, some of the smaller operators who don't enjoy who don't have the engineering and the development teams that some of the larger operators have. How are they reconciling this desire for more open platform, the promise of network functional virtualization, the promise of that, the ability to pick and mix and the benefits that ensue from that, with the need for getting the stuff built and having a credible, trusted provider? So how are you seeing them reconcile that? And I'll take that one to Matt first and then to you afterwards, David.
I'm not wanting to be too pessimistic, but I think in most cases we're not yet. I had a good conversation last week with an operator you traditionally call a follower, for want of a better term, in Southeast Asia, which has quite ambitious plans for moving to 5G and has been looking to virtualize and very much was talking, we want to do this in a cloud native way. We want to make sure this works and keeps all the doors open and so on and so forth. But we've had to go with one of the traditional network equipment providers, of the big 3 or 4 there, and we've had to take their very proprietary closed stack solution because they're able to give us people that can help with this, and they're able to assure that it will work, and etc., etc., etc. And the question they were asking me is, how do we deal with that? For this particular individual I was speaking with, it wasn't just the case that they didn't have the skills internally, but actually within their country, do they have people with the software skills they need in order to do this? It's a complex question. I think we are seeing operators trying various initiatives to move in that direction, but it remains to be solved.
And David, the last minute, anything, your observations, anything you've seen in the track, any observations you'd make about that, reconciling that need to balance openness with robust, trusted delivery?
Yes, I suppose the one thing that I would sort of throw into that mix there is that a lot of the ability for smaller players to be able to reap some of those benefits of open platforms will come from, or ideally will come from, when some of the sort of standardization efforts and the efforts around automation sort of bear fruit. Because at the moment, of course, operators are more dependent on the sort of the integration services and the support services that vendors can provide. But if NFV does become more sort of automated with sort of open sort of APIs and ability to actually pick and mix more, because standardization has coalesced, I think that will perhaps release a lot of potential. But we seem to be forever sort of not quite getting there, and there's still a lot of issues and differences between different standardization bodies to resolve.
Thank you very much, David. Unfortunately, we have got there and we've come to the end of our hour. I'd like to thank both of you for the presentations. I'd like to thank everyone else for joining in the session, and for those who raised questions, thank you for your contribution. As I say, we will be sending the slides and the results from the polling, and also hopefully continuing to tackle these key questions in our research. So thank you all. Good afternoon, good evening, and for those of you in the States, good morning.